Take a look at the picture on the screen. Here you can find that a rainbow has been shown. Now, if you look closely, you will find that the red light or the red color is at the top of the rainbow and violet color is at the bottom. So what can we say? We can say that since red light is on the top of the rainbow, it has bent or curved less. And since violet light or the violet color is at the bottom, so violet light has bent or curved more. So why do you think this is happening? Why does violet light bend more than red light? Let us find out. Now, if you recall from our previous discussions, we had studied that violet color or violet light has a small wavelength of roughly around 400 nanometers. On the other hand, red color or red light has a large wavelength of around 700 nanometers. So, as you can clearly see, the wavelength of red is clearly much more than the wavelength of violet. Now take a look at this relation. We have come across this relation before in the case of waves. What did we learn? We learned that velocity is equal to frequency times the wavelength, or V is equal to F into lambda. Now if we keep the frequency constant, what can we say? We can say that when wavelength is increasing, the velocity will also increase. Likewise, when the wavelength is decreasing, the velocity will also decrease. That is, keeping frequency constant, if we change wavelength, accordingly the velocity will also change. Thus, as we can see, red light had a greater wavelength and violet light had a lesser wavelength. So for a constant frequency, whose speed or velocity do you think will be more? Obviously, the velocity of red light will be maximum and the velocity of violet light will be minimum. Why? Because the wavelength of red light is more than that of violet light. Now let us revisit an old concept. We had studied about the refractive index of one medium with respect to another. Now we know that how a rainbow is being formed in nature. It is formed due to the fact that tiny raindrops are acting as prisms. So there is a change in medium, that is from air to water. So how can we find out the refractive index in that case? The refractive index will be given by the velocity of ray in vacuum or air divided by the velocity of light ray in the particular medium. That is, the particular medium in our case will be the water droplet. So since the velocity of light ray in vacuum or air is a constant, that is 3 into 10 to the power 8 meters per second, we can say that the refractive index or the absolute refractive index of the medium will be given by 3 into 10 to the power 8 meters per second divided by the velocity of light in that particular medium, that is depicted as V. So we can say that the refractive index will be given by this expression. Now if you observe closely, the denominator indicates the velocity of light ray in the particular medium, no matter what medium we consider. So if we consider glass medium, we can say that the velocity of red light is more than that of violet light. Why? Because the wavelength of red light is more than that of violet light, keeping the frequency constant. So when the denominator is more, the value of refractive index will be less, and when the denominator is less, the value of refractive index will be more. So thus we can say that the refractive index of red light in glass medium is 1.513 and the refractive index of violet light in glass medium is 1.532. As you can clearly see, the refractive index for violet is more than that for red. Now, what do you think is happening? This is happening because the velocity of violet light is less than the velocity of red light in glass medium that is being considered. Now, if you recall, we had studied that in a glass medium, refractive index that is less for red light than that of violet light, it influences the bending of light in that medium. So since the refractive index of red light is less than that of violet light when we are considering glass medium or any other medium, we can say that red light will bend less than violet light. Why? Because refractive index is a quantity which gave us a measure of the amount of bending of light which it underwent in a medium. So thus we can say that red light will be bending less than violet light because the refractive index of red light is less than that of violet light. So we can say that when the refractive index of a medium is more, the bending of light towards the normal will be greater. And when the refractive index of a medium is less, the bending of light towards the normal will be less. So this is the reason why we saw that violet light is bending more than red light, because the refractive index for red light is less as compared to that of violet light. So if we come to a conclusion, we can say that since the refractive index of red light is less than that for violet light, the bending of red light will be less than that of violet light, because the bending depends on the refractive index of the medium. And thus we can say that violet light bends more than red light. So it is due to this reason that when you see a rainbow in the air, you see that red light is at the top and violet light is at the bottom, because a rainbow is also formed due to refraction from tiny raindrops which act as prisms. So since again there is a change in medium, and because in that medium also violet light has a speed that is lesser than that of red light, it bends more than red light, because the refractive index for violet is more than the refractive index for red light.